Hey guys, so this is our lesson on 27.3, standard deviation. So we've talked a little bit about standard deviation before, but now we're going to kind of go a little bit deeper with what exactly it is and how we calculate it. So here we go. So by the time we're done with this video, we want to be able to understand what a standard deviation is and also be able to calculate the standard deviation for a set of numbers. So first off, what the heck is the standard deviation? So we have a formal definition with a lot of big words. So for a set of numbers, the standard deviation is the square root of the variance. So what on earth is the variance? So the variance is the average of the squared differences from the mean. But that's kind of a confusing definition, so let's break this down. So really, the standard deviation tells me how close most of my data is to the average, to the mean. So when we use mean and standard deviation as a measure of the center and the spread of data, we learned on Monday that our data is symmetric when we use these measures. So if our data is symmetric or normally distributed, it looks like this. And so, technically speaking, the standard deviation tells you how far away 68% of your data is from the mean. So, if I were to add the standard deviation to the average and subtract it from the average, 68% of my data would fall in that area. So what it tells me is if I have a really big standard deviation, then most of my data is kind of spread out away from the mean pretty far. But if I have a really small standard deviation, then more of my data is closer to the mean, and so my numbers are all a little bit closer together in my data set. Okay, so that's what a standard deviation is. Now we want to know how we calculate the standard deviation. So we've got this equation here that we can use to find the standard deviation, and it's a little bit weird looking, so let's talk about it. We've got the mean is x bar, so the average is this number right here. And then the n is the number of numbers in your data set. So here's n. So what we want to do is we want to take all of our numbers in our data set, each x value, and we want to subtract the average from that and square it. And then this sigma here means that we're going to add up all those things. And then we're going to divide by n minus 1, so the number that there are minus 1. And then we're going to take the square root of that. But that's kind of a lot, so we're going to break it down into small steps. So let's take this smaller set of numbers right here, these test scores, 99, 86, 57, 76, and 88. And we're going to find the standard deviation for this. So the first thing we need to do is find the average. We want to find the mean, that x bar. So I found the mean already, it's 81.2, but basically you would just take these numbers and add them all up and then divide by 5 because there are 5 numbers in our data set. So that's what n is for this set, 5. Okay, so I'm going to make a table to help me with the rest of it. So this is a big table, but basically over here we have our test scores, so all of our numbers from our data set up here. And then in the second one, I'm going to take the number from our data set, the test score, minus the average, so minus 81.2 for each of these. So 99 minus 81.2, 86 minus 81.2, all the way down the line. And it's okay to have negative numbers at this point. Then what I want to do is I want to take this number that I get right here, and I'm going to square it. So 17.8 squared, 4.8 squared, negative 24.2 squared. So I'm going to find all of these squareds. And then the last thing I'm going to do is add them all up. So if I add up every single number in this column, I get 998.8. Then I'm done with the table. So from there, I'm going to take this and I'm going to divide it by how many there are minus 1. So in this case, there's 5 numbers. I'm going to divide it by 5 minus 1, which is 4. So 998.8 divided by 4 is 249.7. Then my last step to find the standard deviation is to take the square root of that. So the square root of 249.7 is 15.8. So my standard deviation for this set of numbers is 15.8. But wow, that was a lot of work. Okay, and what if we had a really big set of data? Like, what if I had a whole bunch of numbers, a whole class worth of test scores? I wouldn't want to go through and calculate all of that by hand. That's a lot of work. Luckily, there's a solution. Desmos has a way to calculate this for us. So we're going to take this bigger set of numbers right here, and I'm going to jump over to Desmos and use that to help us calculate. Okay. So once I jump over to Desmos right here, I can go to Add Item, and I'm going to add a table. And in my table, I'm going to put my list of numbers right here under X1. So I've got 23, 32, 45, 67, 87, 98, 99, 45, 65, 76, 32, and 100. And they don't have to be in order or anything. Desmos will understand. Then I'm going to click down here and open up another bar. And I'm going to go down to Functions. And where it says Functions, I'm going to click on the Stats tab. I already have mine clicked. And we're going to go down to this thing that says Stdev for standard deviation. And I'm going to click on that. And it opens up standard deviation. And if you notice up here at the top of your list, it says X1. That's the title of my list. So when I scroll down here and have my standard deviation, I'm going to do X shift underscore 1 to get X sub 1. And just like that, it tells me what my standard deviation is for this data set. It's 28.3. Wow, that was so much easier, right? Instead of doing all that work, you just have to type it into a table and hit standard deviation. And Desmos can tell us a lot of things. It can tell us, if we click on functions again, it can tell us the mean, the median, the minimum, the maximum, the quartiles, all those kinds of things for our data set. So I'm going to also just go ahead and find the mean here of X1. And oh, look at that. My mean is 64.08. Awesome. That was so much easier. Okay, so I'm going to jump back to our presentation here. So now you give it a try, but with Desmos this time. So go ahead and find the standard deviation and the mean for these two data sets. And then kind of compare them. Which set has a larger standard deviation? And then what does that tell us? Okay, so for your homework tonight, or for tomorrow night, whichever day you end up doing it, make sure that you use Desmos instead of doing it all by hand. Be so much easier. And have fun. Be nice to the sub.